Homework 4.4, Exponential and Logarithmic Equations, Video 3. Homework due Friday, May 29th at 11:59 p.m. The following video and the one after it are associated with homework questions 6 through 10. In the previous two videos, we solved exponential equations by rewriting one or both sides of the equation until we had the same base on both sides. And once we had the same bases with different powers, we basically cancel the bases, set the powers equal to each other, and then finish solving. But there's a big assumption in those types of problems. You're going to be able to get the same base on both sides. That's not always possible. For example, in solve 2 times e to the x equals 11, it is tricky. It's not technically impossible, but it's not intuitive and very tricky, for lack of a better word, to get both sides as powers of the same base. So how can we solve when we can't get equal bases on both sides? Answer, use logarithms. In the previous homework's video series, the last video was about the change of base property. I kind of used a technique there that we're going to use here, but I kind of gave it away that we're going to use logarithms. This approach requires a series of steps. So we're going to title this, How to Solve Exponential Equations Using Logarithms. Step 1. Isolate the exponential term. Translation. Find the part with a power on it and isolate it. In this equation, who has the power? Who has the x? It's not the 2e, it's just the 2. And in case you forgot, e is still the natural base. So if we're going to solve this one using logarithms, the first thing we should do is isolate this. Meaning, if there is any number outside that red dotted circle, get rid of it using the correct move. In this case, I need to get rid of the 2. It's multiplied, and so I have to divide both sides by 2. So we'll have 2 times e to the x divided by 2 equals 11 divided by 2. The 2's cancel, leaving e to the x equals 11 over 2. Now we could call it 5.5, but not all fractions come out as pretty decimals, so it's okay. In fact, it's desirable to leave it as 11 halves. Once you've isolated the exponential term, your second move is to take the log of both sides. And technically, you can use any base, but knowing that we will be using a calculator, we should use log or ln. In the homework, I think it will tell you which one it wants you to use. It says natural logarithm or common logarithm, so log or ln. That being said, I would always use ln with one exception. If the base is 10. Because if the base is 10, using a log of base 10 makes sense. Otherwise, I would just use ln. And for those of you going into calculus, ln will always be the logarithm of choice. So, let's natural log both sides. Now, why is that advantageous? Well, the same reason it was advantageous when we were discovering the change of base property. We're solving for something currently in an exponent by taking the log of both sides. It allows us to use the power rule, and that's step 3. Use the power rule. Because you should have a power on an argument inside a logarithm. And remember that the power rule says you can bring down the power off of the argument and put it in front of the logarithm. So x times the natural log of e equals the natural log of 11 over 2. At this point, the x, or whatever the variable is, should be in a position where you can easily solve for it. So, finish solving. Now, don't let the natural log of e multiplied by the x intimidate you. This is just x times a number, whatever the answer to that log problem is. I know how to get rid of things that are multiplied. I can divide both sides. So if we divide both sides by the natural log of e, that isolates the x, which was our ultimate goal, and we get the natural log of 11 halves over the natural log of e. And at this point, we've technically solved it. However, 2 comments. Number 1, never leave ln e in an answer. Because although most natural log problems don't have nice answers, this one does. I know we've seen it at least once before, but do you remember what the natural log of e equals? You can technically put this in a calculator, but if you remember 2 things, you don't need to. Thing number 1, the implied base of natural log is base e. So we could rewrite it as log base e of e. And the second thing to remember is what a logarithm is asking you. A logarithm is asking you what power will turn this base into that argument. Well, since the base and the argument match, the answer is 1. You need to just know, period, that the natural log of e is 1. Write it on your forehead, walk around, have people ask you, why is that on your forehead? Why is what on your forehead? ln e equals 1. Oh, because I'm supposed to remember that. So please try to just commit to memory that the natural log of e is 1. Now you can put it in a calculator, and then when you get 1, you should smack yourself for not remembering that it's 1. So, natural log of e is 1, which means that this is just the natural log of 11 halves over 1, but it's divided by 1. The other thing I want to tell you about these problems, especially when we get to the ones that use logarithms, is that the homework will ask you for 2 versions of the answer. It will ask you for the exact answer, and it will ask you for an approximate answer. In other words, get out a calculator and give me so many decimal places. Looks like these are asking for 2 decimal places. I wish they would be consistent. And one problem it was 3, and another it was 4. Now it's 2 decimal places. I'm not going to put the calculator in front of the screen. Actually, I will. But I'm going to put the one-line calculator because the display calculators, you can see the problem, and as long as it looks like natural log of 11 over 2 in parentheses, you're good. But it's worth telling you how to do this one in a one-line calculator. Remember, in a one-line calculator, it will calculate the natural log of whatever is parked here. So I have to get 11 halves in there before I press the ln button. Now, if I just press 11 divided by 2, I don't have 11 halves in there yet. I have 2. I have to finish that division problem by pressing equals. Now that I've got the answer to 11 divided by 2, now I can take the natural log of it. To 2 decimal places, 1.7. Just to confirm that that is the correct keystrokes. Let's see. Natural log, Natural log of 11 divided by 2. The whole fraction is inside the logarithm, and we get the same answer as before. Now we're going to do another example, but it's going to follow mostly the same protocol. Isolate the exponential term, take the log of both sides, use any base. I would use ln. The only exception is if the base was 10, then I would use log. Why? Because log of 10 is 1, for the same reason that natural log of e is 1. Once you've taken the log of both sides, use the power rule to remove the exponent, and then finish solving for the x. We'll take a look at another example in the next video. I will warn you that the next example will bring up a blast from the past.